So welcome back. We are going to do the analysis of our hypothesis, and I will show you how to do it. So click on Analyze and go to Regression and go to Linear. In here, we are going to do our different regressions, and we will end up doing three different regressions. Every group will do three different models, three regressions, and I will start with the simplest one, and I will finish with the most complex one. So for this example, I will take the role of group 1 and 2. I will assume that my variable, the important one, is sustainability awareness. So I will show you how to do it for group 1, but I will also do quickly the test for everyone else. So you can also check if the numbers are correct. But let's do it all with groups 1 and 2. So the first thing you need to do is add your AI variable as the dependent variable, and that applies for everyone. Everyone has the same dependent variable. And independent, I mean, you can do like I do, and let's see if we get the same numbers, but independent, you should put your independent variables. So groups 3 and 4, technology literacy, 5 and 6, locus of control, and so on. But I'm taking the role of group 1, so I will do sustainability awareness in here. And then I will go to statistics and I will click on collinearity diagnostic, and then I will click continue, and then I will click OK. That's it. It's a simple model, only my dependent versus my independent. Let's see what happens. I will click OK. So I think in our quantitative lecture, we learn a little bit about how to interpret these things, but we need to test four things. The first thing that we need to check is the ANOVA significance. Is, is the model fit significant? The answer is yes, because this number here is less than 0.1. That's what matters. If if this is more than 1, more than 0.1, we cannot do anything, and we will just move to the next model because we cannot really interpret nothing. It's like this model doesn't work. Let's move to the next one. But good luck, it works. So we can move to the next step. Okay, so we survived the first test. We move to the next thing. The next thing that we need to check is the R square, and we will check the adjusted R square. The adjusted R square tells you how much variation on the variance of the dependent variable is explained by the variance of the independent variable. It's only 5%, but in social science, that is not a problem. That is low. I think something that is 2%, 3% is still okay. It also makes a lot of sense because we only have one variable, so our model explains 5% of the variance of the dependent variable is very weak, but it's okay. Also, it's social science, so there are many things that cannot be covered. I would be worried if this was an engineering model and the outcome of our machine or whatever is explained by only 5%. That would be worrying. Like imagine that you are flying an airplane where whatever you do, the outcome on you only infer on 5% of the outcome. That's very dangerous. So in engineering, you want to have super high R square, like 99.9%. But it's also because it's a machine, but humans are complex, so it's always difficult to explain the variance of the outcome with a model. So as long as it's not zero, and also the opposite, as long as it's not 95%, like 0.95, that will be very weird. I will not trust it. As long as it's something in between 0.02 and 0.95, it's fine. So just double check that you don't have like super high or extremely low R square. The next thing, that's test 2 and we passed it, is the multicollinearity thing. Multicollinearity is when you have two variables that behave very similar, you will get an issue. It's like if you ask for experience and age, sometimes they are very closely related because the older you are, the more experience you get. So in a way, you're asking twice the same question, and you will get that with the BIF here. If this is higher than 4, we have a problem. You should, it's similar to the Cronbach alpha. If you have something higher than 4, maybe remove one of the two problematic variables. But we don't have that. Of course, it's 1 because we only have one variable, so we won't have the problem in this model. And finally, the last test, the fourth test, is to check the significance of the independent variable, the sustainability awareness, and the sign of the coefficient. So first of all, the significance is less than zero point 0.1, and that's very good. So that means that there is a significant effect, there is a significant relationship, and the relationship is positive. So that means that if you have high sustainability awareness, you will use more AI. So I don't remember how you set your hypothesis groups one and two, but if you set the hypothesis that the effect or the relationship will be positive in there, then you will support your hypothesis with these results because you pass all the tests and finally the sign is what you expected to happen. If you set a hypothesis that the relationship will be negative, you will reject the hypothesis. Okay, so that's the first test. Everything worked out nicely. We will do more tests and let's see if it works, if it still works well. The next thing to do is to add control variables because the first model we did, the only dependent and independent, it's quite weak. We only have two variables. Let's do a more complex model, model 2, with control variables. So let's select all the controls, click here, and then click OK. And let's do the analysis again. Everything for the fourth test. First of all, is the ANOVA test okay? Is the model fit fine? The answer is yes, because the significance is less than 0.1, so we pass. What about the R square? It improved. Now it's 0.21. That's what happens when you add control variables. That's the main reason of adding control variables, because of course maybe age is important, of course maybe the level of studies is important. They play a role in all of this. We cannot interpret them. That's not our objective, so we don't even care. But we discussed, sorry, it is 0.133 because it is the adjusted R square, not the R square is the adjusted R square because we have two tails. We assume normal distribution. I mean, don't need to go into statistics that far. It's only important that you understand we focus on adjusted R square. It improved because we have control variables. So we passed the second test too. Let's check the third test, the multicollinearity. We also don't have multicollinearity because nothing is above 4. Everything is less than 1.3, so no problem. And finally, let's check the significance of the variable that we care about, the sustainability awareness, only this one. So it's 0.027, the significance, and the coefficient is positive. So the same conclusion. We pass the whole test and it's positive. So if the hypothesis was positive, we support the hypothesis. Let's do the final model. In the final model, we are going to add the other variables. So the variables from the other groups, the 4. So we add them and let's see what happens. Let's do the analysis. And for this one, pay attention because the results will be the same for everyone. So let's go and take a quick look. First of all, the significance works. So the model fit works. It's fine. It's less than 0.1. It's good. Then the adjusted R square is 0.145. It improved because we added more variables. We passed the second test. Third test, there the multicollinearity, we don't have multicollinearity because it's nothing higher than 4. We are fine. And the variable that we care, now that I take the role of group 1, is not significant, 0.551. So now it doesn't matter if the sign is positive or negative, it's not significant. So in model 3, the conclusion is that I do not support, I reject the hypothesis, not support, I reject. So for sustainability awareness, model 3 is rejection. The final conclusion out of everything for group 1 is partial support because in 2 models you support, in 1 model you reject. So that's, and remember, this is if you have positive in the hypothesis. If for some reason you stated negative, you will have full reject because it's two times you reject, and the last one, the significance is not there, so you reject. So that's the interpretation for group one. For group two, I will, for group two is the same because it's also sustainability aware, but for group three and four, which is um, the technology literacy, for them, the significance is less than zero point 0.1, so we can interpret something, and it is positive. So that means that technology literacy has a positive relationship with AI usage. If this is your hypothesis, you also support. Okay. So the other group's locus of control is not significant, so you reject. Skepticism, you reject because it's not significant, and professional aspirations, you also reject. Maybe I can quickly do the analysis for the other groups, like uh, I can quickly do them, and I mean, you can pause and see what I'm doing. I will do the direct models for technology literacy. I will do it now. So technology literacy works, positive. So it seems that technology literacy has a positive relationship in the first model. In the second model, with the control variables, it works, it works, it works, it works. It's positive, so the same. Second model works, and in the third one, it also works. So technology literacy, if you assume a positive relationship, you have full support. It's full support because in the three models, you have consistency. It's the same for all of them. So congratulations, technology. Well, I mean, there is no right or wrong thing, but it feels nice that you support. So, I mean, technology literacy, you have full support. Let's move to focus of control. Focus of control, the model works, R square, oh, it's close, but okay, no problem. And the significance of locus of control is positive, and significance is fine. So if you assume positive relationship, you support for locus of control in the linear model, in the first model. Second model for locus of control, it works, it works, it works, and significance, no. So second model, reject. Third model, reject. When you have significance higher than zero point 0.1, it means that there is no relationship, that is not significant, the variable, so you reject. So for locus of control, your conclusion is partial rejection. Partially, you found that partially there is no relationship. Let's move to the next variable. I think we did locus of control, so that means the next one is going to be skepticism, I think. So the direct effect with skepticism is, oh, here, good learning. In this model, the model fit doesn't work. It's more than zero point 0.1. So we cannot do anything. We cannot move forward. We just say that model one doesn't have model fit, and that's it. Just one sentence, and then you move to the next model. Let's move to the next model. The next model is with more controls. So we add these controls. And now it works. This works. This works. And skepticism significance 0.319. So no, it's not significant. There is no relationship. So you reject whatever hypothesis you had. And in model 3, you also reject. So one, it didn't work. And two, rejections. The final conclusion is full reject. Okay. So you cannot interpret the first one. You only interpret the other two. So the conclusion is full reject. Then let me do the final model for the groups with professional aspirations. So the direct effect, let's see, works, 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 and the significance, okay, and positive. So if you assume positive relationship between professional aspirations and AI usage, you support in here. Let's do with more variables. It works, it works, it works. Significance, it doesn't work. So rejection. So I think this is similar to locus of control. I think that the conclusion is in the first one you support, but in the other two you reject. So the final conclusion is partial rejection. So that's it. That's the regression analysis, how you do it. I did it for all of you, so you can double check for everything. In the next video, I will teach you how to now move from here to the Excel. So I will show you how to do it.